day, grade 9 learners. I hope everyone is in good spirits. I am Mrs. Aline Leayatko, your science teacher. Quarter 4 finds us dealing with physics, the science that helps us understand and explain why things around us behave as they do. The topic for this video clip is on mechanical energy, its components, and conservation. It begins with a recall on the related competency in grade 8, and this will be used to understand the present topic. Highlighted in this video are vocabulary words, lead questions, and learning tasks to help you appreciate the topic and answer your activity sheets. If you're studying this week's lesson with your classmates or friends, please remember to observe proper health practices and protocols. Disinfect your study area, wash your hands properly, refrain from touching any part of your face unless you have properly washed or disinfected your hands. Wear your face mask because there could be exchange of saliva when you talk animatedly. Hindi maiiwasan ang masayang pagkukwentuhan. And of course, observe social distancing. You may begin viewing today's lesson. I'll see you afterwards. CYL, catch you later.
Hello, it's science time once again. This time, let's talk about physics. Good day to all. Welcome to our science class. Today's topic is about mechanical energy, its components, and conservation. We will briefly review potential energy and kinetic energy, then proceed with an exercise that will have us demonstrate mechanical energy as a whole. To learn more effectively in our lesson for today, let me give you some gentle reminders. First, no phones. Put away your phones as it will help you focus on the lesson on hand because at this hour, learning is our priority. When we discuss, we exchange ideas with the group. Remember that learning is a two-way street. You learn from us and we learn from you. Take notes. Not everyone has a photograph, so it is a good habit to write ideas that will be helpful in understanding the lesson. And of course, plan. You need to plan what activities you have to complete and submit for this lesson. So these are gentle reminders. Next, what to expect in this week's agenda. First of all, we will have a brief review of what you have studied in grade 8 last year. And we will relate these concepts with our present topic in grade 9. Second, we have this particular title for the week's agenda. ME equals PE plus KE. Later on, we will be able to understand what these letters mean. Now, the topics for this week would consist of potential energy, kinetic energy, and mechanical energy. Then we will have differentiation, inference, and demonstrative activities. So are you ready? Good. Let's begin. Grade 8 most essential learning competency number 3 gives us differentiate the potential energy and kinetic energy, identify and explain the factors that affect potential and kinetic energy. From this LC or milk, we had this word bank or key concepts. Energy is the ability to do work. The unit for energy is joule, represented by capital J. Next is potential energy. which is energy stored in an object. So it's also known as energy in position. So position, potential. Next is kinetic energy. When an object is moving, it has kinetic energy. Thus, KE or kinetic energy may be defined as energy in motion. Potential energy is energy in position. Now let's try to review the concepts using pictures. We have here 3 pictures. Okay. First one is a stretch rubber band. So does this object possess potential or kinetic energy? It has potential energy because it has the potential to move. The rubber band is stretched and can be released anytime. Second picture, a player who's going to shoot a ball. Kinetic potential. Good. The ball has potential energy because it is still in a position to be thrown by the player. The last one, a released basketball. Is it kinetic or potential? Correct. The ball possesses kinetic energy as it has been released by the player and is moving on its way to the ring. That's good. You remembered your lesson on potential and kinetic energy. Grade 9 Most Essential Learning Competency number 23 gives us perform activities to demonstrate conservation of mechanical energy and to infer that the total mechanical energy remains the same during any process. We have our word bank. Mechanical energy is the sum of the potential and kinetic energy in a system. What is now a system? It is a collection or group of objects organized because of a common purpose. An example of a system would be a bicycle and someone riding a bicycle. That's a system. We could also use the solar system as an example of a system. All of the objects in the solar system are heavenly bodies. Conservation of mechanical energy. This states that the total amount of energy in a system remains constant in the absence of dissipative forces. When we talk about dissipative forces, we mean forces that can actually break the system or how smoothly the system runs. So it can break out the system from that particular situation. So these are our key concepts for today. Now let us discuss and analyze together 3 questions. Let's have question 1. Differentiate the 2 basic forms of mechanical energy. So you have potential energy, which is associated with height or position, and kinetic energy that is associated with motion. Question 2. Describe the 3 types of potential energy. Gravitational potential energy is possessed by an object due to its position or location. So an example would be a book on top of a table or a rock on a cliff. Next, elastic potential energy is for objects that can act like a spring or a rubber band. So when you stretch a rubber band, it possesses elastic potential energy. And the last one is chemical potential energy, which is associated with chemical bonds that give energy when broken. One example for this is a nuclear bomb. Number 3, define mechanical energy using a mathematical formula. So in this case, ME or mechanical energy is equal to PE plus KE. This means that mechanical energy of a system is the sum of the potential energy PE and kinetic energy KE. So let's have learning task 1. What are PE and KE? This task aims to differentiate kinetic energy from potential energy. Identify each situation, whether each situation has potential energy or kinetic energy. If the situation is classified as potential energy, indicate whether gravitational, elastic, or chemical. Number 1, a mango fruit high up in a tree. This is gravitational potential energy. A ball rolling down a hill. Since the ball is rolling down a hill, it is moving, then it is kinetic energy. A large stick of dynamite. What does a dynamite do? When it is lighted and when it is lit, it can explode. So a large stick of dynamite would possess or would have potential energy and what type? Chemical. A stretched Chinese garter. Since it is stretched, so it means that it possesses or it has potential energy. What type? Elastic potential energy. A meteor falling towards the earth. Correct. That is kinetic energy. Learning task 2. The objective of what about me? The objective for the task is analyze the transformation of energy between kinetic and potential energy and show that the mechanical energy of a system remains the same at any instance in a given situation. Now you are to complete the missing values in the table given the formula ME is equal to PE plus KE. So let's have number 1. You have PE at 50 and ME at 120. So the KE is 120 minus 50 equals 70. Next, KE at 40, ME at 70. Using the formula, ME minus KE equals PE. 70 minus 40 equals 30. Number 3, PE 30, KE 80. So 30 plus 80, we get 110. Number 4, ME at 50, KE at 25. So 50 minus 25 equals 25. And last, ME at 45, PE at 20. So 45 minus 20 equals 25. Okay. I hope everyone got the correct answer. Okay. Let's analyze and discuss together. What we have here is a pendulum that is hanging from a point and swings from A to E, in which only the gravitational force is acting on it. So what do you observe with the PE and KE values at different points of the pendulum? And what do you observe about the total mechanical energy at each point in the pendulum? So at any point in the pendulum, there are corresponding values of PE and KE. So for example, you have point C, PE is at 0, while KE is at 10,000 joules. Pag ganyan, ano ang total mechanical energy? So you just add PE plus KE, 0 plus 10,000 joules equals mechanical energy is equal to 10,000 joules. So, pag tinignan mo from A, B, D, and E, when you add potential energy to kinetic energy, you will get 10,000 joules. Any loss of potential energy will result to a gain in kinetic energy and vice versa. So, pag sinabing vice versa, any loss in the kinetic energy will result into a gain in potential energy. There is no loss of energy in the system, and the energy is conserved. And the last one, the total mechanical energy at any given point in the system is constant. The value of mechanical energy remains the same. Now, activities illustrating mechanical energy. The pendulum diagram demonstrated mechanical energy by showing at which point the KE or the PE is at its highest or at its lowest value. The photographs in the next slide show other activities that demonstrate mechanical energy. Analyze each photograph, then determine at which point the KE and PE values are in their highest or lowest value. So you have here a roller coaster, you have a hammer, you have a girl dropping a ball, you have a skateboarder, a bowler, someone stretching a rubber band, you have a man hitting on a nail, you have another pendulum, and last you have a swing. Now these activities or photographs, you will use them for learning task 3. How do I illustrate me? The objective of this task is to demonstrate activities that show conservation of mechanical energy. After you have studied the different activities in the slide, okay, you choose one activity that you're supposed to do. It is either a video presentation or still photographs. Now, for video, if you choose to do a video presentation, submit a video with narration of your activities at home that show how conservation of mechanical energy is demonstrated. The length of the video recorded should not be more than 1 minute. Or if you choose activity number 2, which is photographs, perform 2 different activities and take 2 clear captures of each activity for a total of 4 photos. Label each photo with the possible values of KE and PE. Would it be high or low at a given capture? High KE, low PE, o kaya high PE, low KE? Now, you should be clearly seen performing the activities in your chosen presentation, whether you choose to do a video or send still photographs. Now, you will send the video or photographs to your science teacher through FB Messenger. In case you are not able to send a video presentation or photograph, you submit an essay or a drawing that fully describes what activities you performed. So you have there the rubric or the scoring guide for this learning task. Lowest score is 4, highest score is 10. Okay, so let's have a short quiz. Now in this quiz, you have here the first part. The question is, what is your opinion? So, which of the following systems easily demonstrates conservation of mechanical energy and why? Choices ninyo, playground swing, seesaw, and playground slide. So those are the choices. On the right side of the screen, you have there a table and a drawing, an illustration of a man who's going to push a ball down the hill or down the slope. Now, in the table below, you have their values for PE, KE, and ME. However, not all of them are filled up. So what you're going to do is to complete the table with the correct answer. Next. Okay, so the summary for today's lesson, let's recap. 1. Energy is essential to everyday life. 2. The two forms of mechanical energy are potential energy and kinetic energy. 3. Energy cannot be created or destroyed, but it may be changed from one form to another. And recap number 4, you have there mechanical energy is equal to the potential energy plus the kinetic energy. So where do we apply our knowledge of mechanical energies? Ba ginagamit yung mechanical energy na yan? There are a lot of situations wherein mechanical energy is used. One example is that it produces the electricity that fuels our homes, which is actually supplied by potential energy turned kinetic. The source is from an electric plant, fueled by coal, hydroelectric dam, or some other source such as solar cells. The coal is stored potential energy at its most inert. It may be burned to convert itself to kinetic energy. Oh. Now, an example of a power plant that is fueled by coal would be the Calaca Thermal Power Plant in Calaca, Batangas, and the Suwal Power Station in Pangasinan. Other applications for mechanical energy. Counterweights are used for lifting up an elevator, a crane, or a sash window. We usually see elevators at our local malls. Roller coasters are an entertaining way to utilize potential energy. Chains are used to move a car up an incline, building up gravitational potential energy, and then have this energy converted into kinetic energy as the roller coaster falls. So usually a roller coaster is seldom absent in an amusement park. The nearest amusement park from us would be the one in Santa Rosa, Laguna. What else? A hydroelectric dam converts the potential energy stored in a water reservoir behind a dam to mechanical energy. Mechanical energy is also known as kinetic energy. As the water flows down the dam, its kinetic energy is used to turn a turbine. So examples of dams are Caliraya in Laguna and the La Mesa Dam in Quezon City, Metro Manila. Of course, our body converts chemical energy from food to mechanical energy for movement, especially with sports. Okay, so what do we get from knowing and applying what we have learned? Most of our present energy resources are non-renewable and can be easily depleted like fossil fuels, yung crudo, yung coal, yung natural gas. Our national government has begun searching for renewable and sustainable resources that would contribute less pollution to the environment. Geothermal, hydroelectric, wind, and solar resources. Kailangan maghanap ng mga panibagong mapapagkuhanan ng enerhiya para tuloy-tuloy ang supply ng kuryente sa ating bansa. We need to do our part also in maintaining our surroundings clean for humans, plants, and animals. Kailangan pangalagaan natin ang ating kapaligiran because it is the only one that we have. So our reflection for today, using the 2 prompts below, write your thoughts about your experience with today's lesson. I learned that, and I realized that. At this point, I would like to ask if there are any questions regarding the lesson. If there would be questions, feel free to send me a message through FB Messenger. These are our references. Please take note of them in case that you need to read more about potential, kinetic, and mechanical energy. So this is it for this week. This is Mrs. Yatko. Thank you for joining today's class. Take care.
How are you, dear learners? Did you find mechanical energy interesting and easy to understand? If your answer is yes, that's great. I hope you can now appreciate our natural resources, land, water, air, and living things. I am hopeful you will find it easier to complete this week's answer sheets. This is it for now, dear students. I am Mrs. Aline Lea Yatko, reminding all of you to take care of yourselves. We are still under Alert Level 1 of the COVID-19 pandemic. Build your body resistance by eating well, drinking clean water, being active, sleeping enough hours, and staying safe. When you have questions regarding our lessons, you may send me a message through FB Messenger. Hasta la vista, dear learners, till our next meet. Paalam!